So, George, how did you get interested in these kinds of caves and things like that?
Well, my story follows the literary full cycle mode where I came to Carlsbad in 1975, December of 75, pretty much on a whim. I saw that there were two national parks nearby. One of them was Carlsbad Cavern. Well, if it's a national park, it must be something interesting. I went inside and I just fell in love.
Yeah.
And I went back to San Antonio, found cave exploration organizations, which led me to cave science, which led to, getting various degrees up to my PhD, chasing cave experts around the country to study under. Then back to San Antonio to run my consulting company for 20 years. And then I was selected to be the director of the Institute and came here in January of 2007.
Now, just tell the audience what the mission of the Institute is.
That's a great question. Yeah, the National Cave and Karst Institute was created by Congress in partnership with the state of New Mexico and the city of Carlsbad. And its purpose, in summary, is to conduct, support, facilitate cave and karst research, education, management, archiving of data, and collaborations that support all of the above, and to do that nationally and to some level internationally.
Can I ask the difference between, I never heard of a karst before. So can you just say what that is for the audience and for me?
Oh yeah, no, that's what I was expecting is the next question. When I first met my wife, I confused her a little bit. I still confuse her because she knew I was interested in caves and car stereos, and she didn't see the connection between caves and car stereos. And then finally she figured out I was saying karst areas. Karst is a type of landscape, much like mountains and beaches are types of landscapes. And karst covers 25% of the country, but like you, most people have never heard of the word, let alone even know what it means, which is a shame because if we think, for example, of beaches, everyone knows where the beach is, but there's just this tiny percentage of ribbon around the edge of the country, along the shorelines. Karst is a landscape formed primarily by dissolving away the bedrock. This is something that happens over thousands, millions of years, very slowly, but most landscapes form by what we call mechanical erosion. Sand, rock, gravel, moving down slope, grinding up other rocks, cutting down through the ground. But with karst, water moves into fractures and slowly dissolves those fractures. And because they're a little bit bigger, the next time it rains, a little bit more water can go into them, which makes them dissolve even larger and larger and larger. When those dissolved cracks and crevices become big enough for a person to enter, we call them caves. So caves are the natural pipelines for worldwide about 750 million people's water supplies, what we call karst aquifers being these underground reservoirs of water. So where you have space, you can store things in that space. Water is the primary resource that people need, that people value. But you also have amazing ecosystems down below ground. We have some of the world's most important archaeological sites that are found in caves, paleontological sites. Many of the best places to study climate change, people are realizing, is underground in caves. Because if you want to study what's going to happen in the future with the climate, it's very valuable to look at what's happened in the past. And the best climate records are really found in caves. So there's this amazing diversity of work and research and benefits that we get from caves that certainly I expect we'll touch on as we go forward, which most people have no clue about. And that's one of our goals, is to teach people what these things are, why they're important, why everyone should understand the word karst.
Now, have you been in these kinds of caves all over the world?
Yeah. I've visited caves in about 40 countries, done actual research in many of them, and certainly studied and explored caves around the U.S.
So they found this karst, I guess you would call it, in China that nobody had been in before, right? And they went into it and they found have you been in that one?
You're talking about the one with the forest at the bottom? Yeah. There was a big fuss about that not too long ago. I haven't been into that one. I know the people who've been there. I've worked closely with that institute, the National Institute there in China, that studies these things. So yeah, there's a lot more to discover.
I mean, that particular one is huge. Have you been in other ones that big?
There are many that are that big. They have a great concentration in China. I've been in many of these things, some in China and some in other parts of the world.
When you go down into it, George, the only way down is to climb down, yeah?
Well, it depends. In some places, you can walk straight into a cave, or maybe there's a slope you can walk down.
Mm-hmm.
And other places, it's a sheer drop and you get on rope and you have to rappel down and then climb on up out of that.
When you go into something like that, like what's the first thing, like when you're going to rappel down into one, and nobody's been there, or very few people have been there that you know about. What are you feeling as you go down that line?
There's certainly a sense of exhilaration. It's been said that those of us cavers, people who explore caves, we've seen places where more people have been to the moon than to the places that we've been to.
Yeah.
And so the discovery, the exploration is the first thing that attracted me to caves. As time has gone on, I've translated that from physical exploration to scientific exploration. Certainly, I'm not 19 anymore, which annoys me to some degree. Yeah. But I miss being young and fit. But I can't physically do what I could, but I can still study and explore caves in a different way. And in fact, now, one of the differences between exploring a cave when I was 19 to what I do now, because of my technical knowledge, I've got a pretty good idea of what I'm going to see. And so as I'm rappelling down, it's great, it's exciting, but I'm also watching and looking for things to either confirm or disprove my thoughts, my theories. And being disproven is also good. It keeps you sharp.
Now, is there a time of day you're trying to do it, or does it not matter when you're going into a cave?
Usually we go in just during our normal sleep-wake cycle. We go in the morning, come out at night, just because we're freshest during that period. When you're underground, you have no sense of time, in the sense of you don't see daylight. You don't see the sky moving, the sun moving across the sky.
So at first you're going down and you're in darkness. You can't see anything except for the light on your head. And then how do you see there could be anything down there. There could be any kind of thing. It could be animals down there. You just don't know. What do you see as you come down?
Well, it depends on the cave. It depends on how large the entrance is. Most caves, if you're rappelling on down or just free climbing on down, walking on down, the entrances are fairly relatively small, and you quickly move from daylight into what we call a twilight zone, a partially lit area, into total darkness. You see a rapid change from vegetation on the surface, temperature change, to what's happening up above, to what's the stable condition down below. The cave will oftentimes get wetter, but not always. You see a loss of vegetation, because vegetation needs light, photosynthesis. If you have a large entrance, like the one you're talking about in China, those things are large enough where enough sunlight gets down to allow photosynthesis. And in that case, why it hit the media so big was the forest growing out of a cave, essentially. But it's just that there was light, and so trees grew. So what you find really depends on the type of cave that you go into. Some will be dry, some will be hot, some will be cold. Again, it just depends on the situation of each cave. And you've got an idea of what to expect if you've studied these things when you go in. In worst case is if you find something where you're not prepared. For example, if you thought your rope, which is 100 meters long, for example, didn't reach the bottom, well, you then switch over and you climb straight up. You obviously don't get off rope and fall down. So you just, you switch, you climb up and get more rope. Other times you go in and you find that you need more equipment or certain specialized equipment. And so you turn around and you come back either that same day or on a different day with more equipment according to what you need.
Now, when you first land, right, nobody's probably been where you're going. So, do you have to be careful not to, you're entering a new ecosystem. You're a different thing than what's been down there. It's harmful for them, harmful for you. What do you do when you first land?
First of all, just look around, see where I'm at, orient myself. I want to be safe for myself. I want to be safe for the people with me. but I also want to be safe for the cave and whatever it has in it. I want to make sure that there's no, like you said, if there are any animals, anything ecological that I might be damaging, I don't want to do that. As I move deeper into the cave and in the dark zone where you've got stalactites, stalagmites, I don't want to destroy or break any of these crystalline deposits. I want to, look and say which way is the best place to put a path, and then just have one path of minimum impact that I follow and that everyone else then follows. If there are any cultural deposits, certainly I want to avoid those and just mark those. Sometimes we'll actually have like surveyors flagging tape, which we'll leave behind so that people following up and say, let's stay away from that until an archaeologist or someone qualified, to study whatever that material is can come down and study it properly.
Now, sometimes you go beyond where there could be cultural artifacts, because you're so deep in the cave, it's like people would never have gotten there,
Definitely, but also ancient peoples have gone amazingly long distances underground, and so sometimes we've been surprised to find materials long distances underground. Mammoth Cave, for example, the longest cave in the world in Kentucky, they found materials miles from the entrance, human remains and cultural materials where they would be mining minerals from the cave and do other activities. So some ancient people were actually pretty adept cave explorers, having their own torches that they would use, that they would take underground. In some cases, there's evidence that they would use or build scaffolding to get up into high places, because they lived there, they had the time, and if they thought it was important, off they go. They'll take the time and do what's needed.
You were saying earlier, these, are so incredibly important because you're learning about the past. And you're just starting to touch on that. So, what kinds of things, what are you learning that is important as we move forward into a climate challenged crisis world? What do we learn from, people living in this environment?
Well, when it comes to climate change, it's not the cultural material that's of most importance. What's of greatest importance is within the stalactites, the stalagmites that you see in the cave, these crystalline deposits, when they are deposited, when they crystallize, they often trap microscopic bubbles of air. And then if you study those microscopic bubbles of air, you're essentially getting a sample of what the air was like 100,000 years ago, 50,000 years ago, whatever. And you can date the crystal itself to tell you the age of the material. And so you can do a number of tests based on various types of isotopes to understand what the temperature was like in the past, how much carbon was there in the atmosphere, carbon dioxide in the atmosphere, and other gases. Additionally, though, when, and there's a lot of justified focus on the stalactites, on the stalagmites, on these calcite deposits. But the floor itself, people tend to treat the cave sediment like dirt. They say, well, it's just dirt, No, it's sediment. This was deposited layer upon layer upon layer over time to create a thick deposit. And as you excavate down through that, you find pollen, spores, animal bones. So you're recreating through that material, not just what the temperature and humidity was like, but who was at home, what plants and animals were living on the surface. And it gives you a much richer understanding of what's going on. One thing that hasn't been studied in depth yet, but people are starting to talk about it, certainly I've been interested in it, is looking at paleohydrology, because we can look at different water levels in the cave. Where are they now? Where were they in the past? And what did that mean in terms of climate? What did that mean in terms of water supplies? And that then connects back to human activities on the surface, where a spring may have been located at one point to support a community.
Right.
And now we look and say, well, why did these people settle here? There's no spring, there's no water supply. Well, maybe there was in the past. So there's a rich variety of information that can and is gathered.
The stalactites, if they're down there and they're not, there's no human interference, they can get quite large. Yeah.
Yeah.
So how big have you been surprised when you're down in a cave?
Oh, yeah. And that's one of the things I like about it. I mentioned earlier that having a theory proven wrong is not necessarily a bad thing. I don't want to get complacent in what I know. And so it's exciting. It's, to be surprised and say, wait a minute, why wasn't this the way I thought it was? What haven't I learned? What more is there to learn? So it's really great to be surprised and excited in caves.
So how long do you spend down there?
It depends. Depends on how big the cave is. Some caves are very small. You go in and you're out in 5 minutes. Those don't attract a lot of people.
Right.
Other caves are so extensive that you go down, you set an underground camp, and you may stay down there for weeks at a time.
Now, how do you ensure you don't get lost when you're down there?
People worry a lot about that. And really, it's just common sense. When you walk out into the street and drive across town or go into a big, let's say, a tall skyscraper, and you've got different levels and different passages, corridors, and rooms, you just look for landmarks.
Mm-hmm.
You look for the landmark that says, I'm on the 15th floor, and you say, all right, yeah, I remember I turned left at this plastic plant here. You look for landmarks. You look for names on doors. We do the same thing. Our landmarks are different, though. We'll remember the big rock. We'll remember, this washed out area. We'll remember a certain pool. And it's important to always turn around and look behind you, because going one way, the cave has a certain appearance. But when you come back the opposite direction, the cave will look different. You might see, for example, going in this way, there may be a passage coming in from the side that I may not notice. But then coming back, it's like, wait a minute, there's a fork in the road. I don't remember that.
Right.
So it's important to pay attention to landmarks. But someone said a long time ago, I don't remember who it was, being a bit of a wise guy, but also being accurate. People would suggest taking string with you in a cave to not get lost. And this fellow said, if you can carry enough string to not get lost, the cave isn't big enough to get lost in.
Right.
So again, it's just common sense, and it's something that you learn by doing.
If you're down there, how many people, if you're going to go down for a few weeks, how many people will go down with you?
It'll depend again on the cave.
Like, what's an average amount of people?
For most caves, 3 or 4 people is for most caving trips. For a camp, it could be 3 or 4. It could be half a dozen or more. There's some cave camps where people will trade out, where the team will go down, let's say, for a week. And mm-hmm. then as they come out, a fresh team will go down and replace them and bring more supplies.
Wait, I just want to be clear. You go down and you stay down for, you're not coming in and out. And I think for the audience, I'm claustrophobic just hearing about it.
Yeah, you go down and stay down because the limit of exploration is so far that to do any work, you just can't do that on one day's energy.
And so what are you bringing in terms of, like headlamps and things? Because you want to be able to see, but isn't it a balance also to not disrupt the ecosystem down there? So how are you getting materials for research? How does that work?
Definitely. The basic caving equipment is a helmet to protect your head, a chin strap to hold it on your head, because if you trip and the helmet goes flying, it won't protect your head if you hit the floor. You'll have 3 sources of light usually as a minimum, 1 on your headlights, so on your head, so wherever you look, you can see what's in front of you. People worry about the darkness, that it's all dark around you, but I'm not going that way or that way. I'm focused on what's ahead of me. So it doesn't matter if that area is dark. And so you'll have other sources of light, backup sources. You'll have a pack with water, maybe some snacks. Depending on what type of cave you're in, you might have your equipment to descend or ascend ropes, a first aid kit. These are typical useful things that people will carry. If you expect to be in the cave for a long period, then you'll bring, not to be distasteful, but you'll bring a pee bottle, because you don't want to impact the cave. You'll bring, let's say, other supplies if you have to do something else in the cave. You pack it in, you pack it out, to, again, minimize your impact. To minimize impact even further, again, you try to stay on one trail. I was just writing to someone who was asking me about a tourist cave in another country and showed me photos, and it was wall-to-wall concrete, and it's convenient for the tourists, but the ecosystem really depends on that sediment. And I told them that I'm really concerned about that. You need to make that trail as narrow as possible. So even in an undeveloped cave, you want to keep it as narrow as possible.
For the audience listening, though, what is the repercussions of destroying a cave? Like, how bad is that if we screw it up, if we go down there? I mean, I don't think people understand the implication.
Well, we can destroy and damage caves in many different ways. And so the repercussions will vary. If essentially you fill up a cave with concrete, you're building a road that's in the way, you fill it with concrete. Well, you've just now lost the site that puts water into the ground to replenish your water supply. So you may have less water available, incrementally a small amount perhaps, but less water available. On the flip side, we can also destroy caves in a sense by pollution. Caves, karst aquifers are the most vulnerable to pollution of all types of aquifers on the planet. The fact that I've been swimming in many people's water supplies tells you that, this is a sensitive system. I'm not being filtered out. I'm a giant contaminant. I don't taste very good. So if I'm not filtered out, then what about oils, grease, pesticides, microbes, bacteria that may get washed in? Those things are not being filtered out. There's essentially no filtration that occurs in karst aquifers. And so that's also a major concern. I've been in caves where the fumes were so bad because of pollutants that, we just couldn't go in. We had to blow fresh air in, to go in to explore and work in the cave to try to find the source of this contamination. Dumping garbage in caves. People have done this around the world for centuries. They don't have easy access to a proper municipal waste facility. And so they go out to the back pasture and dump their garbage into a cave, out of sight, out of mind, not thinking that that's going into their water supply. So on the biological side, when people think of critters in caves, they think of bats. Bats are the quintessential cave animal, and at least they're iconic in people's minds, but there are many other types of important cave animals as well. But let's focus on bats for a moment. Bats are directly or indirectly responsible for over 450 foods, medicine, industrial products that we use. And so if we destroy bat habitat, we're damaging these other functions. In the US, a study was done some years ago, and most of the bats in the US are insectivorous, meaning that they eat flying insects. Most of these flying bugs are agricultural pests. And so it was determined that on average in the US, American agriculture saves about $23 billion a year in pesticides that are not being applied on the fields. And now that's not even counting the health effects of not having it, run off into our streams, our lakes, our rivers, into our water supplies, not getting into our foods. So there's so many potential benefits and also repercussions from damaging caves. And yet people see caves, they say, oh my God, it's a bat, it's rabid. Any mammal gets rabid. Bats are no exception. But before we start killing bats, because they're rabid, there's other far more severe triggers of rabies and other diseases that we should be concerned about. And so people will want to go and blast the cave shut to keep the bats in there, to kill off the bats. These things are fortunately less common as more and more people are being educated. This program that you're doing, I'm really appreciative of your call for me to do this to help educate the public, because slowly we're trying to get the message out. It's what we're trying to do at the National Cave and Karst Research Institute, and other partners around the world are trying to do the same thing. So those are some of the damages. I mentioned, just to jump around with examples. Let's say, again, we've got the proverbial highway that's being built, and the highway department just fills up a cave with concrete. That cave may have had highly important archaeological cultural materials in there.
Right.
And a part of our history may be lost,
Right.
Never to be known or recovered by those activities. So those are some of the things that can be damaged.
So have you ever run into big bat colonies when you've gone in?
The largest bat colony in the world is Bracken Cave on the outskirts of San Antonio, Texas, which is where I'm from. Mm-hmm. I've been visiting and studying that cave since 1977. In fact, I've got a project there, and it's owned by Bat Conservation International. So it's a great group, for people to connect with for bat information.
When you go in that cave, the bats can fly. Like, what's the experience of going into the cave and just seeing all these bats and the bat guano and all the things that happen in there?
Well, with Bracken, And with most caves that have bats, we try to limit our trips to when the bats are not present. Many caves have seasonal bat populations because they migrate. With Bracken, the bats come up during the summer and they go south into Mexico for the winter. So we try to minimize interference with them. We pay attention to not look up at the ceiling with our lights and disturb them. We try to stay quiet in the areas that have bats. With most caves that have bats, the bats aren't throughout the cave. They're usually roosting in certain areas, and you can move past those areas and then not have any effect on the bats at all. So we know they're there, but they don't bother us.
When you hear them, what sounds are they making?
They'll make a chirping type sound. They'll be awake most of the time that you're there, but it's a high-pitched chirping type sound. But bats are just amazing animals because that chirp sound that we hear is not really necessarily what they hear in terms of their navigation. They use something called echolocation. They'll release this high-pitched frequency that will bounce off of cave walls, that will bounce off a moth that they might eat while they're flying up in the night sky. And they'll be able to fly in and target it. Some people think that bats are bad flyers because they'll see them fluttering around in an irregular pattern. And what they're doing oftentimes is they're zeroing in on their prey.
Right.
And in some bats, they'll actually do a little acrobatic maneuver where they'll catch their prey with their wing, knock it down toward their belly, and then kind of do a flip upside down as they bend over and eat it, and then spread their wings out to go flying. They do it, in the blink of an eye, and people think, "Oh my God, the bats are going to get in my hair." No, the bats are not going to get in your hair, but they're incredibly agile, amazing animals. They spend most of their time grooming. They spend most of their time raising their young. I mean, anyone would be proud to have a bat for a parent.
Let me just say, Jesse is obsessed with bats, George. So this was a wonderful little foray into bats because we've tried to talk to people about bats before we get sidetracked. But why then is all of the mythology? Why did they create Batman? How do we get from your love of this creature, Jesse's love of this creature? Why was Batman like a hero?
Well, it's not just bats, but it's caves in general. Caves have, throughout history, they've had this duality. On the one hand, there's the darkness, which is associated with death and disease and monsters, the unknown. And on the other hand, less common though, but if you go, for example, down to southern Mexico, Central America, you have the Maya culture where they saw caves as a sign of life. Because in these vast karst areas where there was no surface water, they would go into the ground to get water. In some of the large tropical caves, clouds would form when humid air would sink down into the cooler cave atmosphere. Clouds would condense, and so the ancient Maya believed that caves gave birth to the clouds in the sky, which caused it to rain in the fields and caused the cycle of life to continue. So we've got this life and death, dichotomy with caves, but mostly, especially from European origin countries like ours, it's more of this death and darkness sort of mystique, and that gets associated and translated to bats. They don't understand, they're mysterious, they're flying at night, and so they're associated with the devil and all sorts of other nonsense when they're so incredibly, incredibly beneficial.
When you're down there and you're going to be down a couple of weeks, and you go down with a team, I imagine you must already know the team. Yeah. You must know them pretty well to want to spend a month with them underground. Yeah.
You bet. It's not just a matter of, let's say, personality compatibility, but my life is in your hands and your life is in my hands. Yeah. And we both need to be comfortable that we can take care of each other and help each other. And I don't want to over dramatize it. I've often said that the most dangerous thing about exploring a cave is driving to get to the cave. That driving stuff is really scary, real high rates of death and injury. If you know what you're doing and you follow the rules of safe caving, the rate of injury is low. But nonetheless, if you're going for an extended period of time, you want to make sure you know your team. And it's also functionality. You're going down for a reason. Are you qualified to do the job? Am I qualified to do the job? So you want to assemble the right team.
Now, assembling the team, so say there's a cave you want to go to. How do you assemble the team? Do you put an ad out? Is it word of mouth? Is it, how do How do you find the few people who are going to be with you?
Well, in my case, I whip out this handy device where I have about 2,000 of the world's leading cave scientists, explorers here, and I just know who they are and I give them a call. I'll send them an email. And usually it's on that very personal basis that we connect people. We contact the people we know. In some cases, if we don't know someone with a particular specialty or strength we need, we'll go to someone and say, hey, Jesse, do you know someone who has this skill set? Because I know you, Jesse, and you're my good friend. And so you connect me with someone who does.
Now, what's an average day when you're down underneath the ground and you've been there a few weeks? Like, what's an average day that you're going to do?
It depends to some degree on the cave, of course. It depends to some degree on the team and how they work best. Frequently what happens is that a group will go out and put in a long, hard day. And so they may be away from camp, exploring, mapping, doing research for anywhere up to 16, 18 hours. And then they come back and then they take a rest day. And then they go out, and do another very long day. Other times, if there's a lot to do close to camp, then you'll go out and let's put in a typical 8-hour workday, and then go back to camp, eat, get refreshed, and then you go back out the next day. So it really depends on the cave that you're studying.
Now, what's a rest day underneath in a cave?
A rest day will be sitting in camp, getting some extra sleep. You will go over your survey notes, your data, especially if you're mapping the cave as you go. We like to map as we explore. And so we'll say, wait a minute, it looks like this other passage is going to come in to where we're at. And so we can then better plan and be prepared for how we're going to approach our next set of exploration. Look for errors in the data. Did we make a mistake? Did we transpose numbers? Yeah, tomorrow we need to double check this when we go past this one point. So those are things to do. Some people will just sit back, relax. They'll bring a cheap paperback novel with them and read.
Well, it just sounds like a special kind of person that's got to be down there, right? Because to just sort of relax. Jesse, do you think you could go down there and just chill?
It sounds kind of appealing the way you're talking about it.
Jesse and I went to the bot. Where did we go? We went in North Dakota. We took a trip down to see the neutrino plant, and it was, I don't know, like a mile down below the earth.
On an elevator.
Because
it's an old mine. It's an old mine,
But the idea of being under there, it just. Okay, so there's a certain kind of person that can just chill down there. And then what is the reentry like when sunlight, like if you're down there for a week and you come back up, is it like getting the bends when you come up from the ocean? No.
The atmospheric pressure is about the same, so there's no bends or anything like that. But when you're going underground for a long, and you're going to be down for a while, we tend to take our time. And it's two things happening simultaneously. On the one hand, you're double, triple, quadruple checking your gear, making sure everything is right, that you have everything you need. But on the other hand, you're kind of soaking in that last bit of sunshine too, before you go underground. When you come out, you feel it. You feel that difference in terms of the taste of fresh air versus cave air. The sunshine. I remember after one trip where I was down about 3 or 4 weeks, many years ago, I made the mistake. I hadn't really thought about this. I relaxed. I unbuttoned my shirt and just kind of opened it and laid back and rested for about 15 minutes. And I was just sunburned almost immediately because I had no sun exposure for this time, not just here, but on my face. But it's if you do it enough, you just, at least for me, you adjust pretty easily to it. A lot of caving, like a lot of things, I guess, is psychological, is feeling comfortable in whatever environment that you're in. People worry about a cave collapsing in on top of you. Well, if I'm looking at a piece of rock over there and I see a stalagmite that's this big on top of it, that tells me that rock fell 1 million years ago, 100,000 years ago. The chances of me being in that cave, in that spot during the split second when that rock fell, are pretty slim. I think I'm sitting at home right now. I think I've got a much better chance of the roof falling in on me here than it would in a cave. So
when you get down there, you get into an isolated cave. The ecosystem might have been around for a long time, millions of years, and separated from what's up on the surface. How do you study something like that?
carefully, obviously, but this is where you bring in some expertise. So if I've worked with a lot of cave biologists, and what they'll do is they'll go in and take limited samples of what's living there. Unfortunately, the science right now doesn't allow us just to say, oh yeah, I can look at it and tell you everything about this species. No, you need to take it, essentially you need to kill it, preserve it is the proper word, but you're killing it and preserving it. And then you're doing studies, morphological studies on its size and shape, but also genetic studies. And that starts giving us, giving scientists an idea of what's going on. Now, while you are literally killing that one animal, the ecosystem is robust enough that the loss of a few individuals isn't going to hurt it. And you're not going to the cave every day, every week, the same thing, collecting. So they will take, they can withstand a certain level of impact. But I strongly urge that if anyone who's listening, who's a budding biologist and is interested, I strongly urge them to not run into a cave and start collecting animals. Because for one, they may not need to be collected. The cave may have already been studied, but also they may not be preserving them, collecting them in the right way, and they may not reach a proper specialist. So they may be killing those animals for nothing. So, connect with the right people. And in doing that, there are multiple resources. Certainly, the National Cave and Karst Research Institute, our website, nckri.org. For people who are interested in cave exploration, go to caves.org. That's real simple, caves.org. That is the National Speleological Society. It's the longest lived organization involving cave exploration and science in this country. I'm a lifetime member of the NSS. Contact them and you'll learn about where there are caving groups in your area, so they can take you underground, teach you how to do things properly. That again, safe for you, safe for others, safe for the cave.
And George, you're going to retire now. You're at the end of running this organization. So what's next?
Well, it's been an honor to be the director of the National Institute for the past almost 16 and a half years. I miss my wife. That's the main reason I'm retiring. It's kept me very busy.
Did she ever go caving with you or no?
I met her at a caving meeting. So I want to spend more time with her. That's a big part of it. I've been just super busy. But I talk about that I'm retiring from the Institute. I'm not retiring fully. I'll go back to consulting, which is what I did before the Institute, but on a part-time basis. As a director of the Institute, I directed research. I did a little bit, but I really miss being a research scientist as opposed to an administrator. So going back to consulting part-time will be fun. Meanwhile, I don't know who's going to replace me at the Institute yet, but I will fully support the Institute, the new director, because the Institute is so important. And it's why I got away from my real passion of doing research, because I felt I could do more for cave and karst research, management, protection, education through the Institute as director than I could as a consultant. So I will continue to support the Institute as it continues to grow.
Is there one place that you'd love to go? Jesse mentioned the one in China. Is there an area that yet to be explored, either here in the United States or anywhere in the world?
Oh, there are so many places to be explored. The problem is, time and age creeping up on me. I've been invited on some expeditions where I've told them, no, I'd love to go, but I'm just no longer in the physical shape to do those trips. One place that I'd really like to go, which I probably won't see because of the expense and some other issues, is Antarctica. And in Antarctica, 98% of the continent is covered with ice. There's only 2% exposed bedrock. And I've long felt that if we can find some bedrock caves in those areas, then the sediments, the stalactites, stalagmites, the materials preserved there will tell us what was going on in that continent before the ice formed. So there's a lot of great research going on and drilling through the ice, pulling out cores, looking at paleoclimates and so forth. But caves form by flowing liquid water, not by ice. And so by finding a cave like this, we might be able to get some data on what was happening 40, 50, 60 million years ago before that ice appeared in Antarctica. That would be scientifically fabulous, and the exploration, would be just great as well. So that's one place. But there's so many places, so many things I'd like to do, many places I'd love to go back to.
Well, George, thank you so much for spending time with us today. We really appreciate it. Very insightful. Appreciate it.
One last question. Sorry, but when you were sleeping in a cave, do you dream?
Yes.
Oh God.
Yes, of course. I'm sleeping with a roof over my head, as I did last night.
Okay.
So yeah. But again, nckri.org for the National Cave and Karst Research Institute, caves.org for the National Speleological Society, if you're interested in finding a caving club near you. Okay. So thank you so very much.
Thank you, George.
Enjoy
Bye,
the next
guys.
part of your life. Bye.
Thank you.